Hey everyone, and welcome. In Java, we spend a lot of time letting the system catch errors for us. But what happens when an error is something only we can see? A problem with our application's logic. Well, that's where the throw keyword comes in. It's this awesome tool that lets you raise the alarm and really take control of your code. And today, we're going to master it.
So here's our game plan. We'll start by looking at where the normal exception handling kind of falls short. Then, we'll properly introduce the throw keyword. After that, we'll get practical and walk through exactly how to use it and even how to make your error messages way more helpful. And to wrap it all up, we'll look at a real-world example to see why this is such a game changer.
All right, let's get right into it. We all use try-catch blocks, right? They're fantastic for dealing with errors that the Java virtual machine, the JVM, spots for us. But what about the errors that the JVM has no idea about?
And that, right there, is the big question. See, the JVM is a genius when it comes to math. It knows dividing by zero is a no-go, but it doesn't know your business rules. It has no clue that a certain outcome, while mathematically perfect, might be a total disaster for your application's logic. And that's the gap we need to bridge.
Let's start with a familiar sight. In this code, we try to divide 18 by 0. The JVM immediately flags this as impossible, automatically creates and throws an arithmetic exception, and our catch block swoops in to handle it. Perfect. It works just like it's supposed to, totally automatic.
Okay, but now, check this out. We divide 18 by 20. Now in integer math, what's that going to give you? 0, right? And as far as the JVM is concerned, that's totally fine. No rules broken, so the code just runs, it spits out a 0, and that catch block, it never even gets a look in. But here's the kicker. What if, for our program, getting a 0 is a critical failure? All of a sudden, that standard try-catch is completely useless to us.
And this is exactly where we need to step in and take the wheel. To fix this kind of logical problem, we need a way to say, hey JVM, I know you think things are okay, but I'm telling you this is an error. And the way we do that is with the throw keyword.
So what is throw, really? It lets us, the programmer, literally create our own exception and launch it into the system. The second we use it, the program stops what it's doing and immediately jumps to the nearest catch block that knows how to handle that kind of exception. We're essentially creating our own error signals whenever we need them.
Now, that might sound a little complex, but I promise, it's actually a super simple three-step process. Let's break it down.
First, you have to define what your error actually is. An if statement is perfect for this. Second, once you're inside that if block, you create an exception object, just like you'd create any other object with the new keyword. And third, you put the throw keyword right in front of that new object, and boom, you've launched it.
And here it is in action. We do the math, j becomes 0. Then we hit our if statement. Is j equal to 0? Yes, it is. So we go inside the block, and right there we manually throw a new arithmetic exception. That immediately halts everything in the try block and sends control flying over to our catch block. Just like that, we forced our program to recognize our business rule as a real error.
Okay, so we can throw exceptions. That's cool, but we can do better. A generic exception tells you that something went wrong, but a descriptive one tells you why. Let's make our errors more informative.
This is so easy but so powerful. Look on the left, a plain old exception. The output just tells you the type. But on the right, notice we pass a string, a message, right into the constructor. Now look at that output. The error message is right there. Imagine you're debugging months later. This message tells you exactly what business rule was broken. It's a lifesaver. So why do we care about all this? Is this just some neat trick? Absolutely not. Manually throwing exceptions is fundamental to building professional, robust applications that don't just crash when things get weird.
Let's make this real. Think about a super common situation, a primary and a backup database. Your app's first move, it tries to connect to the main one. Now, let's say it can't. The server is up, everything seems fine, but the connection is just refused. That's not a system crash, right? It's a logical problem. So what do? We manually throw something like a connection exception. And what's waiting for it? Our catch block. It catches that specific exception and goes, aha, I know what to do, and immediately tries to connect to the backup. See? Instead of the whole thing falling over, your app just keeps going. That's how throw makes your code resilient.
All right, let's do a quick recap. The most important thing, use throw for your business logic errors, the things the system can't see. Second, you always have to throw a new object from an exception class. Third, remember that throw is a hard stop. It immediately passes control to the catch block. And finally, please do your future self a favor and always pass a clear descriptive message to your exceptions.
And I'll leave you with this question to think about. We've been using Java's built-in exceptions, but what if you could create your own? An invalid password exception, or a product out-of-stock exception? How would building your own custom exception classes give you even finer control over your application's behavior? That's really the next level. Thanks for joining me today.